Welcome to this presentation. This video is about errors and approximations, and the question we are tackling today is about maximum and minimum quotients. A marathoner runs a distance of 10,000 meters measured to the nearest 100 meters in 26 minutes measured to the nearest 1 minute. Calculate the range of his speed in meters per minute. First, before we continue, we'll have to recall that error in a given measurement is usually obtained as plus or minus a half times the least unit of measurement. Now, the least unit of measurement here refers to the level of accuracy a measurement is given to. For example, here we are told that the distance was measured to the nearest 100 meters, and that means that the least unit of measurement is 100 meters. And for the time, we are told it was measured to the nearest 1 minute. That means the least unit of measurement here is 1 minute. So we can begin by getting the error in distance, and that is plus or minus a half times the least unit of measurement, which we had seen is 100. So we multiply by 100, and that gives us plus or minus 50. Now we can use this to determine the limits of the distance, that is 10,000. So to determine the limits, given the distance 10,000, we can determine the lower limit by subtracting 50 from 10,000, and that should give us 9,950. We can also determine the upper limit by simply adding the same. So we have 10,000 plus 50, and that gives us 10,050. That is for the distance. We can also do the same for time. Error in time is plus or minus a half the least unit of measurement, which we had seen here is 1 minute. So we multiply by 1. And that gives us plus or minus 0.5. Now, once again, we can use this to determine the limits in time. So given time as 26 minutes, we can get the lower limit by subtracting 0.5. That gives us 25.5. 26 minus 0.5 is 25.5. And then the upper limit is 26 plus 0.5, and that gives us 26.5. Now we are going to use these limits here to answer the rest of the question. Remember, we are required to calculate the range of his speed in meters per minute. So we are required to get the maximum speed and minimum speed, and from that we determine the range. Now we'll have to recall that speed is given as distance over time, and from this formula we'll be required to determine the maximum speed and minimum speed. And again, we can recall that maximum quotient is given as maximum over minimum. Remember, speed here is a quotient. That means we have a number divided by another, distance over time. So the maximum speed will be obtained as the maximum distance over the minimum time. The same should also apply to minimum quotient, where we can talk about minimum speed, and that will require us to get the minimum distance over maximum time. Well, we can begin by determining the maximum speed, applying this. Maximum speed is obtained as maximum over minimum, so we'll have the maximum distance over the minimum time. Now, maximum distance is the upper limit, that is considering the limits for the distance. So we have 10,050 over the minimum time, and the minimum time here we're going to use the lower limit for time, 25.5. And this should give us 394.12 meters per minute. Again, we can also determine the minimum speed, and for minimum speed we are going to have minimum distance over maximum time, and minimum distance is the lower limit here, and that is 9,950 all over the maximum time, and the maximum time is 26.5. When you divide, we are going to have 375.47 meters per minute. Now, given the maximum speed and minimum speed, we can now determine the range. Now, the speed ranges between, now the minimum speed is 375.47 meters per minute, and then the maximum speed we have 394.12 meters per minute. And this is the range of speed just as required in the question. Now with that, we come to the end of the solution to this problem. Thank you for watching. See you in the next one.